Hey everyone, so this is a tutorial to solve question number 4 in your assignment number 10. So for this question, we have a water tank which is 18 meters long, connected to two pipes, one which is 30 meters long with a diameter of 10 centimeters, and the other which is 35 meters long with a diameter of 5 centimeters. Now what you need to do is to find the velocity or the volumetric flow rate at the exit of this pipe. So let's go about to start solving this question. The first thing that we need to do is do an energy balance or use the Bernoulli's equation between points 1 and 2. Now, you all know that the Bernoulli's equation is this. For 2 points that we've selected over here, P1 and P2 are the same. That is, P1 equals P2 equals to P atmosphere. We also know that the velocity at point 1 would be negligible compared to the velocity at point 2 because the area of this water tank would be significantly larger than the area of this pipe. So we could assume that V1 is almost 0. Also, there are no pumps or turbines in this system, so H pump and H turbine go to 0. So our equation simplifies to Z1 equals V2 squared by 2G plus H pump. Z2 is 0 because it's this point, it's relative to this point over here. Now, if we input the values of all the known variables in this equation, we get 18 equals V2 squared by 2G plus HL. Let's consider this to be our equation number 1. Now, let's look at the two pipe systems. The first pipe, which is 30 meters long, and the second, which is 35. Let's call this pipe Pipe 1, and the second one Pipe 2. We could write the mass flow rates between Pipe 1 and Pipe 2 to be the same, which simplifies to this. Rho V1 into A1 equals rho V2 into A2. As this is an incompressible system, both rows are same, so V1 equals A2 by A1 V2. So we get V1 equals 0.25 V2 once we input all the known values, and let this be our equation number 2. So for equation number 3, we start writing the head loss for our system of two pipes. So the head loss would be the sum of the major head losses and the minor head losses. So once we input all the known values in this equation, we simply get the total head loss as this. Let this be our equation number 3. Similarly, we could write a number of equations for our system. Equation 4 could be the volumetric flow rate is V2, velocity at point 2 or the exit velocity times the exit area, which is basically V2A2 or V2 into this. Let this be equation 4. We could also write equations for the Reynolds number in the two pipes, which is rho V1 d1 by mu, or this, equation number 5. And similarly, equation number 6 is the Reynolds number in pipe 2. We assume that the system is a turbulent one, so the friction factor is given by the Colebrook's equation. So equation number 7 would be the friction factor in pipe 1, while equation number 8 would be the friction factor in pipe 2. So all in all, we have a system of 8 equations, which is given down over here. I guess you can pause the video over here and look at all the 8 equations and make sure that they make sense to you. Okay, so we have 8 equations and 8 unknowns. So the unknowns being the volumetric flow rate, the velocity in the two pipes, the total head loss, Reynolds number in the two pipes, and the friction factor in the two pipes. So These are our 8 equations and 8 unknowns. So we know that this equation can be solved. This system of equations can be solved. How do we do that? Well, we're not that good at math, so we could use something like MATLAB. So we use the function fsolve in MATLAB, which is basically taking a system of nonlinear equations and it solves it for you. So for now, let's ignore this x over here and look at all our system of nonlinear equations. So we have 8 system of nonlinear equations. Let's look at F1, which was this in our case. So F1 is basically 18 equals V2 by 2G plus HL, so Z2 equals V2 by Z1 equals V2 squared by 2G plus HL. Now, we could write equation 1 as this over here. How fsolve works is that you need to write down each equation equals to 0. So basically, equation 1 would be 18 minus V2 squared by 2G minus HL equals 0. That's the way fsolve works, and that's how you need to write down your equation for F1. So basically, F1 would be Z2, which is 18, Z1, which is 18, minus V2 squared, which is x3 squared, divided by 2 into G, minus x4, which is HL. So I forgot to mention one thing over here, is that before you start writing all these equations down, you need to specify what your variables will be. So for my system of 8 equations, my variables are x1 is the volumetric flow rate, x2 velocity at point 1, x3 velocity at point 2, and x4 HL, and so on. So basically, for my system of unknowns over here, this is x1, x2, x3, x4, x5, x6, x7, and x8. So basically, this was F1, where we wrote 18 minus V2 squared by 2G minus HL. So what would it be for x2? It would simply be V1 minus 0.25 V2. Let's see if that's what it is. So x2, which is V1, and x3, which is V2. So we have V1 minus 0.25 V2. And that's what we thought it would be. So that's V1 minus 0.25 V2. So similarly, we write down all the 8 equations for all of these 8 equations, and we start to solve. So now let's look at this x that we initially ignored. So this x is a guess value that you need to put into your fsolve function, and your fsolve solves your equation based on these guess values. So this is like an initial starting point for your fsolve to get to your final answer. Now let's look at my variables. My first variable is the volumetric flow rate. I have no idea what that is. Let's put that down as 1. Then we have V1, V2, and HL. I have no idea what these are either. So let's put these down as 1, 1, and 1 again. Now let's look at x5 and x6. These are the 2 Reynolds numbers. I've made an assumption that the system is a turbulent one. So I know that my Reynolds number is greater than 4,000. But I'm not sure how much greater. So let's just put these down as 4,000 and 4,000 again. Now we have F1 and F2, which are the 2 friction factors in the pipes. I'm not sure what these values are, but I know that their range is in the 10 raised to minus 2, in the order of 10 raised to minus 2. So let's put these down as 0.01 and 0.01. So we have a guess for all our 8 systems, or all our 8 variables. So let's solve this. We click 1, and we see that our equation solved. So let's look at what the final values are. Okay, so we see that the volumetric flow rate is this. The two velocities are over here. This is the total hair loss. This is Reynolds number 1, 2, and friction factor 1 and 2. We see that the Reynolds number is in the order of 10 raised to 5, which is way greater than 4,000. So our assumption that the system is a turbulent one is correct. So we have all the final answers for all of our 8 variables. And this is how you solve a system of nonlinear equations. Now, if the Connect system has a problem with this answer, so you just need to multiply 9.53, if I remember correctly, with this answer, and you should get your final answer to be correct on Connect. So this is how you solve a system of nonlinear equations, and I hope